All right, so this is AP Calculus. Today's date is October 29th, 2019. October 29th, 2019. Okay, so we're talking about implicit differentiation today. And implicit differentiation is just basically when you take the derivative when you have x's and y's mixed together. So what is our objective today, someone?
Take the derivative.
Take the
derivative.
derivative?
With respect of x and isolate the y prime.
Exactly. All right, so let's talk about what we're... the notation can be confusing, so let me make sure I have that correct. So if I say the derivative with respect to x of x, I can rewrite that as dx over dx, because that's the same thing as multiplying a fraction, right? I can think of that x over 1 and multiply them together to get dx over dx, and dx over dx is what? It's 1, yeah. Because anything divided by itself is 1. However, when I take the derivative of x with respect to y, I promised it would happen since we did derivatives in Unit 2. This is now going to be what?
dy over dx.
Yeah, the derivative of y with respect to x is dy dx. And that is interchangeable, so I'm going to do an arrow that goes to the left and to the right, or a Claire that goes to the left and to the right. That is interchangeable with this guy right here, with y prime. So if you see y prime, that's the same thing as dy dx, the derivative of y with respect to x, which is interesting. So if I take the derivative of x, it's 1. If I take the derivative of y, it's y prime, which means normally we had a dinner, and when your dinner was 1, you're good, but you'll never have a dinner that's 1 whenever you're dealing with a y. Your inner will probably be a y. That means dinner is y prime. It's no longer just 1. You'll always have a dinner when you're dealing with y. So really, really remember your dinner when you're working with y, especially on this lesson, tomorrow's lesson. Tomorrow's lesson is more advanced implicit differentiation. So let's try it out. I'm going to take the derivative with respect to x of 3y to the power 4. So give me doubter. 12y to the power of 3. What's dinner?
Y prime.
Dinner is y prime. And there's the answer. I mean, I can just squish them together if you want another simplified version. It's 12y to the power of 3 y prime with no little dot in between, but there it is. Dinner will always happen whenever I'm working with a y. Let's try example number 2. What's my doubter?
-2.
My doubter is everything, I guess. -2. And then normally I just take the derivative right away. So the derivative of y is just
Y prime.
y prime. So this is just -2y prime. So I shouldn't say you'll always have a dinner. I guess I was incorrect. You'll always have a y prime that comes out of it somehow, either from a doubter or from a dinner. In this case, it was just the doubter. I didn't even have a dinner because I can't take the derivative again. It would be y double prime, which is totally different than y prime. And then example 3, I would say, is the most confusing thing, at least in the top 3 most confusing things this entire unit.
Can I try out?
You want to try it?
Say x, y prime.
That's what most people say, and it's not correct.
Is it a product rule?
It's product rule.
Uh,
Most people see xy and they do what Gio said in there. Oh yeah, it's just
x, y prime.
xy prime. So it's product rule. So someone shout out product rule one more time. 1d2 plus 2d1. All right, so what is 1?
X,
What is d2
y prime.
plus? What is 2?
Y.
What is d1?
X prime.
1.
X prime is just 1. So it's just xy prime plus y. And this obviously gets more advanced and more advanced, where instead of just giving you xy, I'll give you -3xy or -3xy squared. So it's not just going to be xy, I'll be, oh yeah, I even give you an example like that. Example number 4, -2xy squared. It's going to be product rule again. So let's write it out. 1d2 plus 2d1. And before we take the derivative, let's talk about why it's product rule. Someone tell me why. Yeah, the x and y are being multiplied. I have 2 variables that are being multiplied. That's the key. I see 2 different variables. It could be x and then some other x with a different function. In this case, they're just 2 variables. All right, what is 1? Negative 2x. D2 is 2y, and don't forget your dinner, 2y, y prime.
Oh, that's weird.
I'm going to pause here because that can be confusing. 2y was the doubter, y prime was the inner.
The second part would be negative plus negative 2.
So 2 is what?
Oh,
Y squared. And D1 is
negative 2.
negative 2. So I guess if I simplify this thing, I'm going to get, I guess I could factor out a negative 2y as well. So I can do that. You'll see this form, negative 2y times, it's going to be 2, what is that going to be, 2xy prime. I'm seeing what's left over if I factor out the negative 2 and the y. Well, I have a 2xy prime left over. We can all see that?
What happened to this 2y squared?
And then I'm about to do that, yeah. So plus, and then when I take out a negative 2, that's gone. When I take out a y, that's gone. I'm just left with y. So this is plus y. So knowing how to factor these is important as well. All right. So the general rule of thumb, and we're basically going to be done with the notes after this, I think. Oh, yes, we are. Okay. No, we have example 5. Okay. Implicit derivatives. The general rule of thumb is just take the derivative. And then to isolate the y prime. And what is another name for y prime? dy over dx, exactly. So if you're being very formal about it, you'll say dy dx because you know what you're taking the derivative with respect to. Because sometimes, especially on this unit, you'll take the derivative with respect to t, time. But y prime is quicker notation. So let's try one implicit differentiation. Here we go. Let's do these steps. We'll take the derivative and then we'll isolate y prime. So take the derivative, go. X squared turns into 2x. Ooh, what about 2xy squared? 1d2 plus 2d1. So what's 1? 2x. Yeah, 1 is the 2x. And then what's d2? 2y. Y prime. Don't forget your dinner. The doubter was 2y because the 2 came down in front, and it's just y to the power of 1. And then you do the next step, which is your dinner. The derivative of the inner, which is y prime. All right. Plus 2d1. What is 2?
Y squared.
Y squared. D1? 2. All right. We've done everything on the left-hand side of the equal sign, so I'm going to now write the equal sign and do everything on the right-hand side of the equal sign. What is that, Claire? 8y prime. That's it. I mean, now we are on step number 2. We did step number 1. We took the derivative. How did I do this right-hand side so fast? So taking the derivative of this thing is this giant thing right here. We're good, we're good?
Yeah.
All right, now let's isolate y prime. So everything that has a y prime, let's put on the left. Everything that doesn't have a y prime, let's put on the right. So does 2x have a y prime?
No.
In fact, maybe let's put the y primes on the right, since most of the stuff that has non-y primes are on the left. This has a y prime. This term has a y prime. So let's move it to the right-hand side. How do we do that?
Subtract.
Yeah, so we're going to subtract 4xy y prime,
Where you got a 4 from?
the 2 times 2. And I'm going to subtract a 4x y prime. When I do that, I'm left with what? Can someone read out what I have?
2x plus y squared plus 2.
plus 2y squared, right?
Yeah.
Is equal to,
a y prime minus 4x y y.
perfect. So now we need to get the y primes even more isolated. So I can factor out a y prime. So if I factor out a y prime is factored out. What's left over when I factor out a y prime?
A minus 4xy.
You can factor out 4 y prime. Or
You
better
could, but
than
we're going to
2y.
just try to isolate only y prime. Otherwise, we're going to have to divide by 4 at the very end. But you're right. We could have factored out the greatest common factor of 4y prime. And then on the left-hand side, I still have my 2y squared and 2x. All right. The final step. Who's got it? Arrow, do you remember how to do this?
What?
What do you do for the final step?
By
I don't know.
Yeah, so divide by what, Gio?
by 2.
Not exactly. So right now, y
By y
prime
prime.
is being multiplied by all this garbage. So how do I do the inverse operation of multiply by all of this garbage?
By y prime.
Divide by all that garbage.
Oh,
Oh, that's what we're doing.
Divide by 8 minus 4xy. Divide by 8 minus 4xy. And we have our answer. You can just kind of scribble that out, but there it is. Y prime is equal to 2x plus 2y squared. All of that divided by 8 minus 4xy.
okay.
And that's the general rule of thumb. I mean, this procedure of getting the y primes on one side, factoring out the y primes, and then dividing by whatever's left over after you factor out y prime. It's going to be almost the same thing over and over again. Very rarely will you have a problem that's harder than that. The hardest part about these problems is taking the derivative when you have x's and y's mixed together. Because that thing does change from equation to equation. All right, give me a fist of 5. How well do you think you can do implicit differentiation? See, a 3, what's there at? A 5 or a 4.5? What is that? And then arrows at a 4. All right, cool. That's the end of the lesson. Good luck on the homework.